Question number 6. We have somewhere here a change in point, and then here. So basically, so this is the graph y equal qx. Now we want to show that y equal mod qx. So we want to turn all the negative y's to positive. So we'll bring a mirror and we'll leave like this. Then this part is going to be so minus 8 9. So then somewhere here it should be minus 8. This is minus 9. It is now positive 9. So this is the mirror image of this one. So I'm deleting this one, and then I want to delete this one. So mirror image is going to be like this. So this is y equal mod qx graph. Next we want to draw y equal q mod x, and so we have to delete this side up to here, and then we'll keep mirror here, then the mirror reflection of this part. So this is 4, then the graphs go minus 4 0 with the symmetricity. So this is the mirror reflection of this one. This is the mirror reflection of this part. Question number 7. A over x, a greater than 0. A value is greater than 0, which is positive. We know that y equal 1 over x graph. This is something like this. So y equal a over x is the same graph. According to the a value, it is moving away or moving towards the origin, and x and y. So this is kx graph. Y equal kx graph. Then we need to draw y equal kx mod value. It means when you look at the graph, we want to identify all the y values, negative y values in the graph, which is this part. If you take any coordinate, you can see negative y's. So now we want to turn positive. So this point is going to be here. This point is going to be here. This point is going to be here. So basically we want to bring a mirror, and when we leave the mirror reflection is going to be like this, and this is the graph for y equal mod kx. Now we want to draw y equal k mod x. Then we need only positive x values, so we don't need this one first initially. And then what we need to do, we want to bring a mirror and leave on y-axis, and we want to get the mirror reflection. So mirror reflection of this one is, let's say, this point, and it is here, this point here. So likewise, so this is the mirror reflection of this one. Um, Assume this is AB point, so this is then minus AB point, just to say a point, just to show a point on this graph. So this is y equal k mod x graph. Question number 8. Y equal mx equal aox a less than 0. So the graph is going to be um, something like this. If a is positive, graph is like this. So now a is negative. So graph is going to be like this. This is y equal mx. Then we want to draw y equal mod mx. So we have to bring this part to up, keep in the mirror here. So it's going to be like this. So this is the mirror reflection of this part. So now this is y equal mod mx. Now I'll go back to the previous one. We want to draw that y equal m mod x. Then left side will clear first, and we want to keep a mirror here and the mirror reflection. So mirror reflection is of this one is this. So this is the mirror reflection of this one. So this distance and this distance should be same. So I have to redraw. Yeah. So this. So like this. Now part B, we want to look at the relationship between mod mx and m mod x. So this is y equal mx mod, and the other one is this one, y equal m mod x. Now we can see that if we turn this graph, if we multiply by y values minus, then it will become this way. It means if we introduce this is negative y value. When you look at this is negative y value. To make this one positive, I want to multiply by another negative. It means y equal if I draw this curve minus m mod x. So this is the graph. So this is same as this one. So y mod mx mod equal minus m mod x. Or what you could do now, we bring this part onto top by introducing minus, or you can bring this one to down by introducing y equal minus mod y equal minus mod mx. Then we make it positive everything, then we bring everything down. So likewise, So this is this graph. Basically, minus mod mx equal mx. But when you look at this is both almost same, because when you multiply by minus you will get this one, but this is different graph, this is different graph. So this one is this one is this. Question number 9. Y equal fx equal e to the power x and y equal dx equal e to the power minus x. So the graph is y e to the power x. Graph is going like that, that is 0 and 1, and e to the power, this is minus x. Part B, explain why it is not necessary to sketch y equal fx, f mod x, and y equal gx mod x. So this is y equal fx. Why we don't need mod fx? Because when you look at this graph, you can see that all the values are positive, and we don't need, there is no negative y values to make it positive. Hence, fx and mod fx, both graphs are same. The same as when you look at gx, y equal gx e to the power minus x, but there is no negative y values. Because of that, gx and mod gx both have the same graph. And the next part, last part, is y equal f mod x and y equal g mod x. We want to draw in the same axis. Basically, we know that we are not interested on left side of the uh, graph after the origin. So this is fx, this is y equal gx. Then when we keep the mirror reflection of gx is this one. So this is the mirror reflection of this gx. And when we consider the other graph fx, so mod fx, so the mirror reflection of this part. If I so draw separately, this is y equal f mod x graph, and this is going to be y equal g mod x. So this is the graph part, and this is the mirror reflection of this part. So this is both graph in one axis, g mod x and f mod x. So this is g mod x. And this part is y equal f mod x. Question number 10. When we look at this one, we can see that this is piecewise defined function. This is this is a line, and this is a quadratic graph. And minus 5 to 2. The boundaries are minus 5 to 2. To get an idea, first of all, I'm drawing, okay. This is negative gradient and minus 6. Okay, this kind of graph I am expecting. This is minus 6, 0, minus 6, this point. This is x and this is y. And this graph, we know y equal x square. We know y equal x square graph. Then x plus 1 square. It means we want to bring, this is minus 1, 0. And then we want to bring 1 down. So basically, this kind of graph I am expecting. This is minus 1, minus 1. Now we have to apply the domain. So minus 5 to minus 1. So minus 5. When x equal minus 5, when x equal minus 5, minus 2 times minus 5, minus 6. Plus 10 minus 6, that is going to be 4. Okay, somewhere is here. So this is going to be minus 5, and this point minus 5, 4. This is one boundary, and this is equal. So the point is there, dot. And what is the end? Minus 1. So somewhere here. Okay, we'll see that minus 2x minus 6, minus 2 times minus 1 minus 6. This is 2 minus 6, which is minus 4. So when it is minus 1, minus 4. And yeah, there is no equal sign here. So graph is in somewhere here. So I put an empty circle because it is not equal to minus 1. Now from here minus 1 to 2. 1 and 2. So when from here to here, it's going to be this graph. So this graph end up with minus 1. Now we'll see that when x equal minus 1, what is this value? Quadratic value. So x plus 1 square minus 1. So this is minus 1 plus 1 square minus 1, 0, minus 1, minus 1. I had to do a small correction. This is not minus 1, x plus 1 square. It means the graph is going to be, we don't need to bring down by minus 1. So minus 1, the graph is going to be something like this. Because accidentally I took this minus 1 to here. Now, when x equal minus 1, when x equal minus 1, so x plus 1 square, x equal minus 1, so minus 1 plus 1 square 0. So then graph is starting from here. it means in this place, and I have to dark it because it is equal to -1, and from here it is going to be a curve when x equals 0, 1, something like this. So when the blast boundary is 2, so when x equal to 2 plus 1 square, that is 3 square 9. So this point, the last point is 2, 9, and minus 5, 4. This is going to be minus 1, 0, and this is, we found out when x value is -1, this is -4, 0. Part A, we need to find the range for fx function. Range means the y values. What is the minimum of y and the maximum of y? So minimum of y, we can see that when x equal at -4, but not y equal -4, but not equal sign. So range is fx. The minimum value -4. Minimum y is -4, but we can't take that is equal sign because this is a circle. And the maximum value is 9, and that is equal. Because -4 you will get when x equal -1. -1 is not equal. So then you can't equal to -4. But this point equal to 2. Because of that you can consider 9 also with equal. Now we want to draw y equal mod fx. Now check any negative y values in the graph. Yes, this is the graph where you will get negative y values. So when we keep the mirror, so it's going to be like this. And we are going to delete. So this is y equal mod fx. Now y equal f mod x. Then I'm not worried about all the left side of 0 of x values. So this is the graph, and when I keep a mirror, so the mirror reflection of this part is going to be like this. So this is -2, and this reflection of this point is here, that is -2, 9. Now this is the mirror reflection of this one. So this is y equal f mod x.